So I will then start sharing my screen in a minute, and don't be afraid. It will be a quick introduction. So it's really just very few slides that I want to show here, and this is mostly to give you an this introduction on what you are about to work with, which is the ESA CCI Toolbox. You maybe have heard of it because it's been around for a longer time already, but in its previous phases there was a web UI, and this is not the case anymore. So what we have now is a Python package, which is a pure Python package. So you will run it as a Jupyter notebook, as Christopher will walk through in a bit. And so to answer this question, what is the toolbox about? It basically serves these two main purposes: to give access to CCI data. At the moment, this is to 22 central climate variables that are ingested into the system that are accessible. And the second thing is that it allows to operate, to work with this data, and the operations are built in a way that they are also applicable to potential other data sets, as the toolbox is not a monolithic system, but it's rather built on this stack of Python packages that are also widely used in other contexts like Xarray, GeoPandas, or Xcube, which are which will become of importance. And also it ensures that with the toolbox we ensure that all the data is available in the same data model, which means that you can compare different data sets and apply the different operations on them, which is something that we will show in the notebook 2 on how to apply these operations. There's just a quick word then about how to get the data, because there we are using certain concept, the concept of stores. So within the toolbox, we have 3 different stores, which is the Zarr store, the Kerchunk store, and the ODP store, where the ODP store provides access to the open data portal from which we get all the ECV data in its different formats. So there they are hosted mostly as NetCDF files, but sometimes also other formats like TIFF or Esri shape files. But through the store, they are read into the system and then provided as Xarray datasets. The other 2 stores, the Zarr store and the Kerchunk store, are sort of convenience stores for certain data sets, as they provide a somewhat faster access. For this training session, we will actually be looking at data ingested from the Zarr store to give you a good user experience. So I have also compiled a few links about the toolbox. I think that most of them are just for the sake of completeness. Like I've included here Pipey and Conda to tell you where the toolbox can be downloaded from. But I think the 2 at the bottom are probably most important. First one, the second one, of course, the training session, to which we will get in a bit. And the first one is the documentation, to which I would point you in case you have any more questions or would like to know anything more about the toolbox. So particular, there is a guide on how you can install the toolbox onto your local computer in case you want to. Since it's open source, you are free to do this and actually invited to do so. And what we recommend is, as it's a Python package, that you use package manager like Conda, so that you first install, for example, Miniconda onto your system, and then you can you have the option to create a new environment given the commands that were listed in the on this page in the installation guide. And if you run them on your local computer, so if you do this command, for example, for creating this environment, which is the one I pasted just here, then the environment will be eventually built. And in the end, you will be able to work with the data also on your local computer, like we are about to do now on the virtual machines or on the notebooks that we have put up. And we will be also around in the later part of the session then to answer questions. So I will take any about the toolbox in case you have any. But for now, I would then switch over to Christopher so he can show us the notebook.
Awesome. Thanks, Tonio. Hi, everybody. My name is Christopher Phillips. I'm a training consultant with Imperative Space, and let's get going. So for folks that are already familiar with Jupyter Notebooks, you obviously know how it works in terms of running each individual cell. For those of you who are less familiar, if you go to the command bar at the top, you'll see a variety of run commands there. And for the purposes of this exercise, we'll be running one cell at a time instead of running all cells, as you can see here, which runs every cell in the notebook at once sequentially. So we're just going to go through. And this is a basic exercise to sort of visualize the data, see how it can be manipulated, and sort of explore it in terms of science goals. So we'll first start with accessing the data. So we'll go through and we'll run our initial imports of packages in Python. This should be a relatively quick step for everyone that has the toolbox installed. We designed this notebook so that essentially you won't have to do any manipulation yourself. We can just run through it. And then at the end, you can feel free to sort of fiddle with parameters and values and all that sort of stuff to sort of explore the data on your own. But for these purposes, we're just going to run through the process of getting the data in and visualizing it. So our first goal is to filter and select our data. As you can see here, we're going to run a simple function, list underscore ECV underscore datasets, and we're going to pass in this string, LST, land surface temperature, which is what we're interested in. And we should end up with a nice selection of datasets. It may take a couple of seconds to load in. And you can see there's a lot here. Some of these may look very familiar to you. You can see different missions here, NVSat, ERS2, Aqua, Terra, Sentinel, etc. And they're also filtered by time of day as well. We have day and night data sets and also multi-sensor and multi-platform data sets. So there's an awful lot in here, that an awful lot of data to be explored. But for the purposes of this notebook, we're just going to focus on one. So as Antonio mentioned, the data is stored in a variety of different stores. For this, we're going to focus on the Zarr store instead of Kerchunk or NetCDF. And so again, we're going to run a very simple function, list datasets, ESA CCI, and we're going to focus on Zarr. And so again, you should see a great selection of data here, all in Zarr format. A lot to explore. And we're going to go ahead and get to the really exciting stuff. So first of all, we're going to define our region of interest, which is going to focus around Leicestershire. So we have a simple bit of Python code here to define our bounding box. And we're going to do that by latitude and longitude, which we define here in these ranges, minimum and maximum, to give us our area of interest, so to speak, which encompasses some urban areas and, of course, some non-urban areas. And so if the notebook is misbehaving for anyone, we won't have won't have time to troubleshoot any technical issues at the moment, but at the end of the session, we can take a look and see what went wrong. So for now, you just have to follow along anyway. So we're going to define not only a geographical region of interest, but we're also going to define a period of time too. So we're looking for data spanning the years from 2011 to 2020, which is available here in the Zarr store. And so we can go ahead, we can define that, specify the data set that we're particularly interested in, which covers the range from 1995 to 2020. And within this, we have subsets of data. If you do see these quite scary looking warnings, don't worry about those. They are warnings, they're not errors. And if you read the comments in the cells here, you'll see that they are expected. And a lot of the time, this is due to working with different data types. You may get these errors. Something to be aware of. When you're actually performing your own science by yourself, data types are incredibly important. So pay attention to them. But for now, you can ignore them pretty much. So from the data set, we're going to explore two subsets, a spatial subset and a temporal subset, which again are just defined by very simple functions that we use here. And within the data set, we have all this metadata, which tells us everything we need to know about the data set we're exploring. Unfortunately, we don't have time to delve in too much to all of this, but you know, after the session, feel free to explore it in more detail by yourself. So we're going to have a look at land surface temperature in our specific region. We're going to calculate the mean data and make a simple plot. And we're going to do this using the climatology operation of the CCI Toolbox, which will help us create a mean over the years by averaging values. Again, scary warning, but you know, we can ignore that. So now we're going to get to the really interesting stuff where we can actually visualize our data. This is the most exciting part because, you know, data as it appears in data sets, in data frames, can be incredibly esoteric. Numbers may tell part of the story, but what we're really interested in is the visualization of this. And so we can create a simple plot using our subsets. And it gives us a wonderful visualization of mean land surface temperature. And just for notation, we have the two urban areas of Leicester and Nottingham here that you can see quite clearly. A note on these plots, I should mention the color scheme that's used in matplotlib in Python, the Viridis color scheme or color map. This has an important accessibility component. So if you're publishing your data, you're writing a paper, obviously you want everyone to be able to visualize and see your data. And so taking into account color blindness, you know, amongst your audience is incredibly important. And one of the recommended color maps for this in Matplotlib and in Seaborn and other visualization programs is the Viridis color map. So something to consider, especially for the young graduates in the audience who may be preparing publications or not familiar with you know, how plots are produced. Very important to take into account accessibility. So now we're going to analyze the urban heat island effect. We're going to visualize that using land cover data, which should load in along with a whole bunch of metadata here. We're going to get down into our subset, our temporal subset, and we're going to select the LCCS class from this. Now we want to make sure that the two data sets are consistent in their visualization, so they have to match. So the resolution has to match, which we'll perform using these functions here. So we're going to create another plot, which is our downsampled land cover map. And you can see here that the the resolution, these are quite large pixels. So a lower resolution plot. So now we want to identify urban and non-urban grid points. Again, there's a lot of code here. For those that aren't familiar with Python, don't worry, it looks intimidating, but it is in fact quite simple. And we can, you can see we've broken it up into chunks and obviously commented the code too, which is incredibly important because it allows people looking at your code to be able to interpret what is actually going on. And so here we have our mask, which we're going to use to integrate the two data sets together. In the first mask, you can see here, we have pixels. These dark pixels represent the urban areas, and the white pixels represent the non-urban areas. And we can see the inverse in the non-urban mask, which you can see here. So now we're going to apply this to the data. Just take a few moments to plot. And here we go. Again, we've adopted the Redis color scheme. Oops, and the kernel has died unexpectedly. Okay, so hopefully that hasn't happened to you. I may just have to restart the kernel here. And let's see if we can get our cells ran again. So let's just wait a few seconds for the plot to reappear. So if anyone has specific questions about the data itself, it's best to direct those questions to the LST science team, who should be in the room with you. They can answer questions about how the data was sourced, the methodologies behind the data collection, and also further questions on how it can be used in analysis.
Yesterday we was focused on the project product, so hopefully by now everyone should be reasonably familiar with the data, but thank you for pointing them to us for further
questions. Fantastic.
Data. Yeah.
Of course, with data, any data, we have our uncertainties. They come from a variety of sources, including systematics, so the sensor itself that's taking the data, sensor noise, atmospheric noise, all these things to take into account. So we're just going to visualize some of the uncertainties now, the collective uncertainties in the data. So if you can scroll down a bit, Tonya. So we can overlay these on the previously plotted data. And you scroll down again, please. Oh, I think we've actually skipped ahead a bunch, to be honest.
Okay.
Yeah, well, no problem. Yeah, so if you want to scroll back up. And
yes, so I was at step 2, or we are going back to
back up, yeah.
That chapter on, this is where it starts with exploring uncertainties, or?
So yeah, we want to go back up again.
Still, okay.
There we go. Right.
Yeah, we were at this point. We left off here.
Excellent. Okay, yeah. So now we were able to visualize the data. As you know, we visualize the uncertainties later on. But one of the interesting things about this data is its time series, of course, and so we can visualize it over time. So if you scroll down, Tonya, please, and again, and again. Here we go. So we can actually see the mean LST over time. And this is a really cool thing about time series data. So we can look at static moments within the data, but when it comes to the sort of the visualization over time, it really does tell the whole story, or tell a more complete story about what's going on, and allows us to visualize trends in the data that wouldn't otherwise be apparent to us. And so, getting an idea of how the data changes over time is incredibly important for anyone that's studying time series. And what's interesting is that, we're focusing on a very localized geographical region here, but one could visualize, time series data over different geographical regions, for coastal regions, for example, desert regions of high elevation, all these sort of different areas that may affect the interplay between the urban and non-urban heat models. So if you can scroll down, please, Tanya. And that brings us to the final section, which is, of course, exploring the uncertainties in the data. And as I mentioned, every data set has an error within it, whether that error comes from, systematics or whatnot. It's obviously incredibly important for the scientific process to be able to understand where those errors have come from and how we can visualize them, and ultimately, how they affect the interpretation of our data when it comes to drawing our conclusions. And so with these final cells, we can run through those. Unfortunately, you folks are having problems at the moment, but this notebook is designed in such a way, as I mentioned before, that you can run through the entire thing without any manipulation of the code or the values. But I think the important thing about this is that it's important to emphasize that you should, after the session, when you have time, you should go in and manipulate the values and explore different data sets and just see what the data can tell you, what the story is there, in terms of, all the data sets we have available to us. And there are an incredible amount of variables, and, you could spend a long time doing this, but it's definitely worth exploring, especially for the young graduates in the room. It's important to get an idea of wrangling data, essentially, and getting hands-on with it, because you'll become more effective and you'll become faster as a scientist when it comes to the analytical process later on during your studies and eventually when it comes to publications. So I think that pretty much brings us to the end of the notebook. And Tony, if you want to scroll down to the very bottom, I don't think we have anything left at the end. Again, apologies for the technical issues. But we're hoping now to do the Q&A session, so I guess we will pass over to the Q&A folks. Once again, thank you very much from all of us. The notebook is freely available when we're all not accessing it at the same time. Yeah, highly encourage you to play with it and get hands-on.
Thanks very much. Thank you. I wonder if it's just possible to remind people where to start to look for the toolbox. Can they just get it if they start from the notebook, or is there somewhere else you need to go to if you want to use the toolbox separately as well? On the CCI web pages or something?
Yes, that was also one of the first links that I had shown. So if you're on the website, then you can find it under data, and then there's the toolbox.
Perfect.
And there's also a quick guide on how you can install the toolbox then.
Thank you. That's really useful to see that. Thank you. Okay, thank you very much. Do we have any questions from anyone? I know we weren't all able to interact fully with that at one point. Yes, Ricardo.
Test. Yeah, thank you for that. I was wondering if you used a number of functions, like self-made functions in the Jupyter Notebook. I was wondering if it will come complete with doc strings and documentation for how to use it and what kind of parameters one can modify.
Yes, thank you for that question. So what you've seen in the notebook, that was that operations were used, and I already told you that this documentation, this is quite an important, or I think useful page to look at, because we have exactly that there also. So we have this API reference, which lists the different operations that are provided by the toolbox, and also gives bit more information about how you can access the different data stores, how to use them to open data, to get descriptions of data. And then there are also additional, there's also additional functionality actually beyond the data access and the operations in the toolbox, which yeah, you might also find useful for certain tasks. But yeah, what you get here definitely is a description then of the operations. Thank you for the question.
Thank you.
Thanks. Any further questions from the room at all? So Karen's reminded me, she sent an email about 6 o'clock this morning, very early, to everyone on the registration list and participating today with some documentation and some links in it. So hopefully you've all received that if you have access to your emails, and that has some additional information in it, I believe, that was sent by the team. So any other questions from the room at all? I think maybe everyone's keen for a coffee, but okay. So thank you very much to the Knowledge Exchange team. We really appreciate your time, and please do explore this toolbox and the Jupyter notebooks. And we're very happy to take, I don't know if you guys have a contact email address for your group. I know it's a very new project, this, by the way, so we're the first people that we've been demonstrated to. So it's literally only started a month or so ago, I think, didn't it? So do you have a contact point, or is it best to field questions through us perhaps and contact you?
So maybe to get back here, we have this one contact point for the help desk.
Perfect.
So that is like the official way to do.
Perfect. That's best. Great. Thank you very much. So if you have any questions about the toolbox or the Jupyter notebooks, please do email the team there. Thank you. Great, thank you. We'll give you a round of applause again. Thank you very much.